Hey folks, welcome back to another video. Today we're looking at question 1572, matrix diagonal sum. The way we'll be approaching this problem is by actually traversing through both the diagonals, adding them, and then returning the sum. One condition that we need to check is that if while we are adding the diagonal elements, is if there's any overlap, we need to subtract it. If not, we just return the sum. Pretty simple problem, so let's get started. The first thing that you need to get is the length. And we know that the length and the width will be the same because of the constraints that are given to us in the question. So let's just get that. And next we need to do is initialize sum to be equal to 0. So we have a for loop that traverses the primary diagonal. So int I equals 0, I less than n, increment I, right? And then what we need to do is sum plus equals mat of I of I. So basically, the index for the column and the row will be the same on the primary diagonal. So it becomes pretty simple for us. Now we need to look at the secondary diagonal. So instead of starting from all the way from 0, we start with n minus 1, right? Because let's say if you want to start with this element right here, 3, so it would be n minus 1. You need to go all the way to 0, so I would be greater than or equal to 0, and instead of incrementing, you would decrement. And sum plus equal. So we have the row. What we care about is the column. So the column would be n minus I minus 1. So if you add the column and the row index, they should be equal to n minus 1 in this case. So basically here it's all right the same, but here it's like inverse. So basically if you add both of them, it should be equal to n, which is like a good trick to have in your back pocket when you need to understand how you get the index of a given element. So basically you will keep decrementing decrementing the rows, and while you decrement the row values, you'll be incrementing the column values because it is the inverse of n minus 1. And once you have that, we know that we've gotten the sum of both elements against the primary and the secondary diagonal. The last thing that you need to check is that if n of modulus 2 equals to 1, right? So we need to subtract the middle element. So what does that look like? It's pretty simple. It's sum minus equals to mod of n divided by 2 and divided by 2. Basically what you're saying, get me the element between in the middle row and the middle column and just subtract that. And how do you know it is n minus 1? So sometimes when you come across questions, if there are examples, it's easy to pick patterns from those examples and apply that to the problem instead of having to think through it entirely on your own. So they've given us two examples, one with n equals to 3 and n equals to 4 in this example. So you see where n is equal to 3, we see that there's an overlap, but when n is equal to 4, there's no overlap. So since 3 is an odd number and 4 is an even number, you can apply that pattern. Once you pick up on that pattern, you can double check if that works for like smaller numbers and higher numbers and like base cases. So if it does, that means you're on the right path and you can continue using that pattern. So that's like a little trick that you can have as well. And then once we've calculated the sum, we just return it. Awesome. Let's try compiling this. All right, the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is of n because we are walking through all of the elements along the diagonals. The space complexity is of 1 since we're not really using any additional data structures to store the sum. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks in the next video. Peace.